one, go for it. You are given the first three terms in a sequence, -2, 5, -12.5, find the 14th term. Hopefully this is like super duper easy for you and you're good to go. We know we're trying to find, I'll even like shortcut it and not write out all the stuff I usually do. Trying to find the 14th term in that sequence. The first term is what? -2. Now how do I find the common ratio here? Yes, I divide the second number by the first number. So I would write that as -2.5 here. And my exponent is to the 14th, that's my n, minus 1. And what do you get when you type that into your calculator? 0.2239. All right, do we all get that? All right, if we can do that, then I feel like we at least should have some confidence that the weekend didn't kill our brains. We still have some of it. Right? Not hard, right? Yeah. Now let's build on this. Let's do a challenging problem. Same idea, but challenging. So we have the first three terms of this sequence are -5, x, and x minus 10. All right, we want to find the value for x, or values, there might be more than one, and the 11th term of that sequence, as a number, not as an x. So let's write what we know. We know the first term is -5. Correct? And we know we're looking for term 11. So we know n will be 11. Do we know the common ratio? No, because we don't know x. So stick with me here. Let's go with what we know, even though there's x's. What would you say is the common ratio between those first two terms? Use the same idea we just used in the first problem. X divided by 5, -5. So that first common ratio is x divided by -5. Are we all okay with that? Now, the common ratio that is between these next two terms, is it going to be the same or like numerically? Like would it be the same number or a different number? Common ratio would be the same. You're always multiplying. So if this common ratio was 3, we'd have to multiply by 3 again. What is the rate, like how do we write the common ratio between those two terms as a fraction? You would take x minus 10 divided by x. Now, would you agree with me that those have to be the same? Yeah. We don't know what x is, but we know that the ratio x over -5 is equal to the ratio x minus 10 over x. How are they going to solve this for x? Math, yeah, good guess. I could do that, but I'm going to think it easier. Cross multiply. We haven't done that in a while. Let's cross multiply here. So if x times x, which is x squared, equals -5 times x minus 10. All right. Do you see where we're going? I feel like some of you might. We're going to distribute. Well, x squared equals -5x plus 50. And this is similar to your bonus on your last test question. What am I going to have to do here? I don't want to, well, I could minus x squared, but then I have to deal with a negative. I'm going to move all the stuff on the right side to the left, because that'll at least just keep things positive in the x squared realm for me. If you wanted to move x squared, that's fine, but then you have to factor out a negative and then factor. Oh, and most of you are on this wall, factor master next to me, so hopefully you're okay. How do I factor this? What two numbers? Multiply -50, add to 5. 10 and -5. Now this is actually we're gonna revisit factoring a lot right after Thanksgiving. This is called the zero product law you have to use here to solve this, and we'll talk about this again. But basically the zero product law says that if I have two factors multiplied together that equals 0, I can take each factor and set them equal to 0 to find the values of x. So what are the two answers here? -10 and 5. Those are my x's. That's half of the problem. I found what x could be. You follow me okay? All right. So now we have to do the last part of the problem, which is to find the 11th term of the sequence. So let's start with x equals -10. Okay, that's where we're going to start. Now suppose x equals -10. What are the three terms of the sequence that we're given? We have -5, What goes in for this x right here? Negative 10. And then the third term would be negative 10 minus 10? Negative 20. So that's the first three terms if I use negative 10 for x. What's the common ratio if that is the sequence? 2. So now that I know the common ratio, could I find the 11th term? Yes, I could find a sub 11, and that would be negative 5 times 2 to the 11 minus 1 power. And can you calculate for me what is that 11th term? Yes. Okay, so that's one option for the sequence. But I could also, for the same x's, have x equal to 5. So I'll pull the screen up again, and I'll pull it up in just a second here. But let's list out the first three terms so we can see what's up. So we could be negative 5 as my first term. What would the second term be for that x? 5, and then 5 minus 10? Negative 5. So if those are the first three terms of my sequence, what is r? Negative 1. So what happens in this sequence? Negative 5, 5, negative 5, 5, negative 5. So they keep alternating. So we know when we find the 11th term here, it's going to be either 5 or negative 5. We just have to figure out which one. It is negative 5. Okay. Good. Makes sense? Could you have gotten there on your own, maybe? Maybe. I think the hard part of this problem is what we did up here with writing the x over negative 5 equals x minus 10 over x. That's the hard part. Once you see it, you're like, oh, that makes sense. But coming up with it on our own is kind of challenging. Last one, flip your half sheet. We have done ones like this before. I'm just refreshing your memory. How many terms are in this sequence? 0.05, 0.75, 11.25. This number here on the end, this is all one number. 569,531.25. That's a term. It's not a comma, it's a term. All right, we're using a sequence, so we're doing a sub n. We want to find the number of terms. So what goes in here for a sub n? That whole big thing here. 569,531.25. That's one number. All right, a sub 1 is 0.05. Can you guys find r for me? How do I find r? Yeah, I take the second term divided by the first, which is 15 to the n minus 1. All right, so I have to divide by 0.05. And I'll just tell you what the number is because I'm feeling nice today. You're welcome. I aim to please. So it's 1,139,0,625. Another big number. Equals 15 to the n minus 1. How do I get n out of the exponent? Oh, yes, our friend, the logarithm. Hasn't disappeared yet. I can't let you forget the logarithm, so I gotta throw it back in every once in a while. So I take the log of both sides. What the challenge is going to be is trying to get it to fit in next semester somehow. Haven't figured that out yet, but I'm going to try. Just you wait. What do I have to do next? Divide by the log of 15. I'm going to save myself some time here. Now, I'm solving for n. Can n be a decimal? No, why not? It's a term number, and term number has to be typically a positive integer. We did see a word problem last week that had negatives, but typically a positive integer. So you can simplify these logs right now. Can someone tell me what that is? 6. So that 6 equals n minus 1. What's n? 7. So that long weird decimal is the 7th. Yes, good job, guys. All right, do we feel refreshed?